Okay, question 8. Two numbers given in their prime factorization form. So if you multiply these out, you'll be able to actually find out what the numbers are, but these are written in prime factor form. You can get the highest common factor of the two numbers by looking at the prime factorizations and seeing which numbers are in both prime factorizations. So 2 cubed is in this one, and there aren't any 2's in the A number. There's a 3 here, but 3 to the power 5 in the A number. Now, if you're looking for the highest common factor, you are looking for numbers that are common to both of them. So you've got a single 3 here, you've got 5 lots of or 5 threes here, so there's only one of the 3's that's common to both A and B, so I write that one down as a 3. 5 is not common in both, however some of the 7's are. I've got 7 to the power of 3 here and 7 to the power of 4 there, so I can include 3 of the 7's because you've got at least 3 7's in both of those prime factorizations. So what is common to both is 3 singularly or to the power of 1 and 7 cubed. They need multiplying together, and that gives you the highest common factor, 1029. For the lowest common multiple, not only do you want the ones that are common to both, so the 3 times 7 cubed is my starting point, it also needs timesing by everything else that you've not yet used. So just going back to this one, I hadn't used any of the 2's, so the 2 cubed needs to come into the calculation. I hadn't used the 5 because that wasn't common to both. That comes into the calculation. But you also need the 3's and the 7's that I haven't yet used. So I had used one of the 3's, which were common. So there are 4 of the 3's, which need to still be included. I'd used 3 of the 7's. So there's one of the 7's that also needs to be included. So 3 to the power 4 and a single 7. And all of those terms need multiplying together to get the lowest common multiple, and you end up with this rather large number here, 23,337,720. Part B is a little bit tricky, I must admit. Okay, so we'll start with the highest common factor of B and C. So I'm only looking at these two here. Remember, for HCF, it is the numbers that are common to both. So 2 cubed is common to B and C, so that P there has to be at least a 3, although it could be higher, so I'm not quite sure what that is yet. And a 7, a single 7 is common. Now, if this R was any bigger than 1, there would be more than one that would be common. If it was 7 squared, then 7 squared would be common. But because there is only a 1 that is common to both of them, then this R number has to be just 1 itself, because that creates a 7 that is just common to both B and C. So R is 1. There we go. Okay. Second part, the lowest common multiple is 2 to the 4 times 3 to the 5 times 5 squared times 7 cubed between A and C. So I'm only looking at A and C. Remember that the lowest common multiples are those that are common and everything else left over as well. So there are no 2's in the A multiplication there. So this has solely got to come from the P here. So the 2 to the power of 4 means that the P number has to be 4 because there aren't any of them up there in A. Okay, so P is 4. Looking at, we've done the R, the Q number is the 5. So 5 squared has to be the ones that are common and the ones that are left over. Okay, so if Q was 1, that would just be a single common 1, which wasn't going to get us our 5 squared. If Q was 3, we would have a single common 1, but also 2 of them left over as well. So it would still be 5 cubed, which is not in the correct multiplication here. So Q is 2, we would have a single common one, yes, and we would have one left over, so Q is 2, giving us P is 4, Q is 2, and R is 1.